Here are solutions to homework set number 8 for ECE 476-676 Advanced Embedded. In this homework set, we're going to take a wet towel and see how much you cool it down when you wave it or blow a breeze on it. So here's what I'm going to do. I'm going to take this wet towel, measure its temperature, and then wave it in the breeze, measure its temperature again, see how much the temperature dropped. Now the first thing I need is a way to measure temperature. I'm going to be using a DS18 B20 sensor. And here's some routines from Bison Academy, elsewhere as well. This will read in the DS18 B20 sensor, set an instance to it, find everybody attached to pin 0, and then read it once a second, display it on the LCD display. So here's what that looks like. As I run it, here's my reading. It's reading 21 degrees. If I put the sensor in my hand, warm it up, you see the temperature in Celsius is going up. I'm getting my readings. I'm fairly convinced that the sensor is working. Okay, now that that works, let's come up with a program that will record the temperature for 20 seconds, 1 sample per second. So here I'm using interrupts that sets the sampling rate. Once per second, I call it 1000 milliseconds and sets the flag. In the main routine, I check to see when the flag is set. Once it is set, I will run through the rest of the routine, set the sampling rate to once per second. I'll read the sensor, send it to a file, send it to the LCD display, repeat for 20 seconds, beep at 10 seconds, beep again when I'm done. And here's what she looks like. So I'm going to open up the file, wet towel, append it to it. This is trial number 4. I will start collecting data. It's waiting for me to start, so I'll take my wet towel, stick the sensor inside the wet towel. There. Nice and set. Hit button 15, that starts it. Again, down here. I'm waiting for button 15 to start. We'll start in 5, 4, 3, 2, 1, starting. I'm now collecting data. Here's the seconds, here's the temperature in Celsius. That's at 10 seconds it beeped. At 20 seconds, double beep, that data set's done. Okay, now that I've got my data, I'm going to take my towel, cool it down. So we wave it in the breeze, 10 seconds, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, highly scientific method here. How much cooler is the towel? So we're going to take this, put it in a nice cool towel. How much did it cool off? So restart my program. Start the data collection. It's now recording data. First data point records once a second, every second. Ten seconds beeps once. At 20 seconds, it closes the file and beeps twice. Okay, I now have my data. What I can do with that is I can now open that up. Let's do File, Open. On the Pi-Pico, there is my text file. Wet towel. These are previous runs. The last data set was trial number 4. Here's the first run. Wet towel. This is after blowing it in the breeze. How much it cooled off. So taking those data sets, repeated this trial 3 times and plotted it at 1 second through 20 seconds, through first trial, second trial, third trial. waving at 20 seconds, seeing how much cooler it is, the temperature for those 20 seconds. You see there is a difference. Waving it does cool off the towel. How much did it cool it off? Well, that's the student t-test. I've got my data. Here's when I started. Here's after waving it 20 seconds to cool it down, what the temperature was at 10 seconds, at 20 seconds. If I just take the last point at 20 seconds, how much it cooled down. First run, it cooled it down by 4.75 Celsius. Second run, third run. Once I have some data, I can do some t-tests. What I'll do is I'll take my data, find the mean, find the standard deviation from a student t-table. Go to stat track, look at 2 degrees of freedom. I have sample size at 3. Degrees of freedom is sample size minus 1. 2 degrees of freedom. 5% tails with 2 degrees of freedom has the t-score at 2.9, 2.92. So I want to go left and right from the mean by 2.92 standard deviations. So here's the mean. The mean was 4.04 degrees cooling, bell-shaped curve. Go left and right, 2.92 standard deviations. And that says, based upon this data, if I repeated this experiment 90% of the time, the cooling will be somewhere between 2.2 Celsius and 5.8 Celsius. And we can check on that. I just ran the experiment again. The cooling went from 21.3 to 17.5. That is 2.5, 3.5, 3.8 degrees Celsius. That is in this range. Had a 90% chance of being in that range. So that is homework set number 8. With a Pico, you can measure temperature, you can collect data, you can throw it in a file, you can read the file later. It is just a great way to collect data. And that's homework set number 8 for Advanced Embedded. This actually uses quite a bit. It's using interrupts to set the sampling rate, using DS18B20 sensor, using library to import it, to read the sensor. Kind of observation. These sensors are actually really nice once you figure out how to use them. Thermistors I like because you can just use an ohmmeter and see the resistance change, but you got to use the A to D input. This one isn't quite as friendly. If you don't have a microprocessor, it's basically worthless. With a microprocessor, with the right library, the temperature sensor is really easy to use. And that's homework set number 8 for Advanced Embedded.